Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in just about any college mathematics course, please consider subscribing, checking out our playlists, watching videos, liking, commenting, sharing those videos. Those are all really simple interactions that you could do that would greatly help us out because it would help us to grow and reach a bigger audience. That said, let's get into the current video. I want to take a look at how to factor any quadratic function. So not just the ones that you see in your class that you're like, you can easily come up with the numbers that work. How to factor absolutely any quadratic function that you could ever come up with. Pretty simple, but let me kind of go through the idea. First and foremost, let's say I give you sort of like a classic example and I give you x squared plus 7x plus 10, right? If you want to factor this, remember the sort of classic scenario where you say, I need to look at all the different pairs of integers that multiply to get 10 and add to get 7. So multiply to get 10, add to get 7. And so when you first start out with these, you're like, okay, well, I know I could take 1 times 10, I could take 2 times 5, I could take negative 1 times negative 10, negative 2 times negative 5, and those are all the integer combinations that you could come up with to factor to get a factor of 10. So then you look at those pairs and you say, okay, well, which ones, if I were to take those individual numbers and add them together, do I get positive 7? And of course 2 and 5 works, so I get plus 2 and plus 5. So what adds to get 7 multiplies to get 10, and that's how you factor that. Well, what if I change this slightly and I say, how about f of x is equal to x squared plus 6x plus 10? Well, I need to find two numbers that would multiply to get 10 and add to get 6. Well, I've already come up with the list over here that I can add, or multiply rather, to get 10, and you see that none of those pairs would multiply to get 6. So does that mean that this does not factor, which is probably what your instructor would say is, well, this one just doesn't. This one factors, but this one doesn't. Well, no, that's not the case. The idea is this one will factor over integers. This one will factor over possibly irrational numbers, as I'll show you. Well, how do we come up with the numbers that would go here? Here's how we use it. Here's how we do this. Remember the quadratic formula? Okay? Quadratic formula says if I've got a quadratic function, ax squared plus bx plus c is equal to 0, then the solutions to this equation would be negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that guy? That's what we're going to use. Let's go ahead and let's find the zeros of this function. So find the zeros of the quadratic function f of x. In other words, set this equal to 0 and solve it, and we'll use the quadratic formula to come up with those answers. Remember, a, b, c in this case would be 1, 6, and 10 respectively. Therefore, the zeros would be x is equal to negative 6 plus or minus the square root of 6 squared minus 4 times a, which is 1, times c, which is 10, all over 2a. And then let's go ahead and simplify this. I get negative 6 plus or minus the square root. 6 squared is 36 minus 40 gives me negative 4 over 2. And as long as you know about complex numbers, that actually makes sense. This gives me negative 6 plus or minus 2i over 2, right? I is the square root of negative 1. And then I can simplify that by canceling a factor of 2, and I get negative 3 plus or minus I as my zeros of that function. Now let me show you how this plays into the factorization. So the way this factors is I'm going to write the original function f of x is equal to x minus first 0 times x minus the second 0, okay? And so therefore I get x minus negative 3 minus I, x minus negative 3 plus I. Let's distribute the negative through. That would give me x plus 3 plus I times x plus 3 minus I. If you want to group these together just so it kind of looks like x plus a number, that's fine. Of course, addition is commutative, so we don't, or associative rather, it is commutative as well, but associative, so I technically don't need those. But just like when we did the x plus 2, x plus 5, this is x plus a number and then x plus a number. And this is exactly how this quadratic function here factors. Let's quickly check. Remember, the idea is you had to find two numbers that multiply to get 10 and add to get 6. Well, let's do that with these two. Let's take the number 3 plus I, and let's add 3 minus I. 3 and 3 is 6, I negative I is 0, so this does give me 6. It adds to get 6. Now let's multiply 3 plus I times 3 minus I. Well, we have to FOIL this, so 3 times 3 is 9, minus 3I, plus 3I, minus I squared. Clearly we can see that the two middle terms cancel, right? And that leaves me with 9 minus I squared. But remember what I is. I is the square root of negative 1. So I squared is negative 1, which gives me 9 minus negative 1. And therefore I get 10. So therefore it multiplies to get 10. Okay. Now again, so this one does factor. It just uses complex numbers. Okay. Let me do another example. Let's do one more example. F of x is 2x squared plus 3x minus 5. Okay. Let's factor this. Now again, if you don't see how to factor it, that doesn't mean that it doesn't. It just might mean that it doesn't factor nicely. But as we saw in the last example, using the quadratic formula, we can easily come up with the numbers that would work. First thing you have to do is find the zeros of this. So the zeros of f of x. All right, that means I'm going to set the function expression equal to 0. And let's use the quadratic formula again. X is equal to negative b, so negative 3 plus or minus the square root of b squared minus 4 times a times c all over 2a. Now let's clean that up. Negative 3 plus or minus the square root. 3 squared, of course, is 9. 4 and 2 would be 8. 8 and 5 would be 40, so I get plus 40. And I'm actually kind of bummed that this is going to turn out to be a perfect square, but be that as it may, divided by 4 is equal to, because I was kind of hoping it was going to be something messy, but I just came up with that just randomly. And then this comes out to be negative 3 plus or minus, of course, that's the square root of 49, all over 4, which would be negative 3 plus or minus 7 over 4. Negative 3 minus 7 would be negative 10 over 4, or negative 3 plus 7 would be 4 over 4, which would be negative 5 halves, or 1. All right, and now whether these are integers, fractions, irrational numbers, complex numbers, it doesn't matter. Whatever I get, the function is going to then be, remember it was x minus the first 0, so negative 5 over 2, x minus the second 0, which is 1. Right? And then, of course, we can clean this up, so I get x plus 5 halves times x minus 1. Now, let me just make one last comment. If we were to FOIL this, does this match the original function? First and foremost, x times x is x squared. That's the only x squared term, but in the original function I've got 2x squared. Okay? And then when I do the L part of FOIL, which is the only way that I'm multiplying just numbers down here, I get 5 halves times negative 1, which is negative 5 halves, but the original function has a negative 5. So those two things don't match. You're like, well, wait a minute, that can't be right then. All I have to do is make one minor adjustment. Whatever the leading coefficient is here, which is 2, I just have to add that as my other factor. So 2 and then 2. So notice x times x would be x squared times 2, 2x squared. 5 halves times negative 1, negative 5 halves. Multiply that by 2, I get negative 5. So therefore, there we go. So all I need to know is the quadratic formula, and you can factor any quadratic function. Thank you for watching. Please consider subscribing.